Welcome to The Explainer. Today we're cutting through the hype and demystifying how modern AI chatbots are actually built. We're moving way past the so-called magic of AI to look right under the hood at the pragmatic, nuts and bolts tech stack of a 2026 production environment. So if you want to know how the systems you interact with every single day actually think, route, and, well, occasionally break, you are in the exact right place. Here's how we're going to break it down today. First, we'll look at why conversation is just fundamentally hard. Then we'll walk through the 4 distinct eras of chatbots. Third, we'll dive into the LLM agent loop. Fourth, we're unpacking the 2026 hybrid stack. And finally, we'll look at what happens when chatbots go horribly wrong. Let's get right into it.
Section 1. Why conversation is hard, or as I like to call it, the absolute chaos of human chat.
To really understand the tech, we first have to understand the fundamental problem we're trying to solve here. And the reality is, human conversation is incredibly chaotic for any machine learning system. Let's look at a super practical example. Think about booking an airline ticket. A user says, "Hey, I want to change my flight." Okay, the system has to figure out their intent, what info is missing, how to get it, and how to execute the action. Sounds straightforward, right? But what happens when a user suddenly changes their mind right in the middle of the task? Literally out of nowhere, they say, "Wait, actually, what if I cancel instead?" Boom. This is where things get incredibly complex. Because every single wrong step is visible to the user, the system has to flawlessly track context, switch tasks completely on the fly, and somehow preserve the state of the conversation. It might even need to take real-world actions, like charging a credit card, without making a single mistake. The input is totally open-ended, right? But the output has to remain perfectly coherent. It's like walking a tightrope without a net.
Moving to Section 2, the 4 eras of chatbots, and this is really an evolution by failure.
What's really fascinating about this industry is that it hasn't just steadily improved on a straight line. No, it has cycled through 4 distinct paradigms. And here's the kicker. Each new era was introduced specifically because the previous one failed too visibly. We can trace this journey super clearly. We started with rigid, rule-based systems like ELIZA way back in 1966. Then, in the 2000s, we moved to searchable FAQ systems. Around 2016, we tried unpredictable neural models, and finally, we arrived at the autonomous LLM agents we use today. Let's break down exactly why each of these shifts happened.
First up, rule-based systems. These rely on hand-authored patterns that match user input to predefined flows. Now, don't get me wrong, rule-based systems work brilliantly inside narrow, safety-critical scopes. Think banking authentication, where hallucination is absolutely 100% not tolerated. But their fatal flaw? They fail immediately and honestly, spectacularly, the second a user steps even an inch outside of that strict design.
So, because rigid rules failed so hard on general, open-ended queries, the industry shifted to retrieval-based systems. Think of Zendesk's classic similar articles feature. You encode every pair of utterances and responses, and at runtime you encode the user's message to essentially retrieve the nearest stored response. This handles paraphrasing way better than rigid rules, and it completely eliminates hallucinations because, well, there's zero text actually being generated. But as you can guess, it completely lacks the ability to generate any unique, context-aware thoughts. It's just a really fancy search engine.
To get fluid, natural conversation, tech giants tried neural seek-to-seek models between roughly 2016 and 2019. These were trained on massive conversation logs to generate responses completely from scratch. Sounds great in theory, but these failed spectacularly in production. They were incredibly prone to just giving generic outputs like, "I don't know," or they drift completely off topic, or just generate pure, factual nonsense. They were practically never reliably on task.
Which brings us to Section 3, the LLM agent loop, planning and acting. So, to fix that factual drift in the utter helplessness of those early neural networks, we needed systems that could actually think, act, and verify. And that brings us to the modern LLM agent. But before we break down how the agent works, let's bust a little bit of jargon. You'll hear the term tool call thrown around a lot. A tool call is simply a function invocation. It's literally just the LLM emitting a structured call asking the runtime environment to go execute a real-world function, like searching an internal database or sending an email. Another super vital term is RAG, which stands for Retrieval-Augmented Generation. All this means is that we retrieve relevant, factual documents first, and we inject them to ground the LLM's response before it generates any text. It's like giving it an open book test.
It ties the agent to reality so it doesn't just make things up or hallucinate.
And this brings us right to the core of modern AI, the LLM agent loop. Listen, an agent is not just a chatbot with a really long prompt. It's an iterative controller cycle. The agent makes a plan, it calls the tool, it observes the result of that tool, and then it decides what its next step should be. It loops this process over and over, checking its work until it finally returns a polished answer to the user.
Section 4, the 2026 hybrid stack. This is really about getting the best of all worlds. So, how does all this build into the reality of 2026 production environments? Well, the secret of modern chatbots is that those 4 paradigms we just discussed, they aren't sequential replacements, because absolutely no single architecture handles every type of request perfectly. Today's production stack uses hybrid routing to intelligently direct traffic. Destructive actions, like processing payments, go straight to safe, deterministic rule-based systems. Simple questions, they go to retrieval-based FAQs. And the complex, ambiguous tasks are routed to our modern LLM agents armed with RAG and tools. It's a grand synthesis, the ultimate best of all worlds approach.
And now, Section 5, when chatbots go wrong. Failure modes in production.
Okay, we need to shift our tone a bit here, because even this highly sophisticated 2026 hybrid stack has a dark side. It's fraught with serious security vulnerabilities that we absolutely cannot ignore. Consider Echo Leak. This was a 2025 zero-click data exfiltration flaw discovered in Microsoft 365 Copilot. It carried a terrifying 9.3 out of 10 CVSS severity score. And what triggered it? Literally just an agent reading an attacker-controlled malicious email. That's the whole exploit. It is a textbook case of why giving agents right access to our tools is incredibly dangerous.
This devastating kind of attack happens through something called prompt injection. It's actually officially ranked #1 in the OWASP top 10 for LLMs. It happens when malicious user input is designed to secretly override the system's core instructions. It can be direct, like someone pasting a command right into the chat, or indirect, hidden as invisible text inside documents the agent reads. And it is vital to know this: no amount of clever prompt engineering fully eliminates this risk. None.
Now, if you're sitting there thinking this is just some rare edge case, let's look at the data. In specific high-risk setups, like adaptive attacks against AI coding agents, attackers have achieved an astonishing success rate of approximately 84%. 84%! Now sure, while general tool use attacks might sit a bit lower, around 0.5% to 8%, a vulnerability rate even that high in your orchestration layer is just completely unacceptable for enterprise security.
And unfortunately, prompt injection isn't the only risk on the table. To build robust systems today, developers have to defend against a whole suite of failure modes. There's confident fabrication, where an agent flat out lies and claims it completed a task it didn't even start. There's scope creep, infinite loops, where it just repeats tool calls, and context window exhaustion. Defending against all this requires incredibly strict architecture. We're talking step budgets to force-stop those loops, strict logging, isolating tool outputs, and implementing external runtime defenses, like a plan, verify, execute pattern, where the agent actually has to verify every single action against its original plan before it actually pulls the trigger.
This whole journey, from strict, safe rules to these incredibly powerful autonomous agents, reveals a massive trade-off between capability and control. So, I want to leave you with this final thought. As we give these incredibly powerful hybrid agents more and more tools to act in our real, physical world, can we ever build a truly immune AI agent? Or is this deep vulnerability simply the unavoidable cost of giving machines the autonomy to act? Are we truly prepared for the consequences when they are inevitably tricked into using our own tools against us? Something to think about the next time you ask a chatbot to summarize your inbox. Thanks for joining me on this explainer.